So this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through negative indices. So what we're looking at is taking a base, say A, stands for any number, and raising it to a number that's negative. So something like a to the power of -1. So how are we going to decide what this is equal to? There's no real intuitive meaning behind it. I mean, a to the power of -1, you can't times a, or any number, by itself -1 times. So how do we define this? How do we say what this is equal to? Well, we actually define it in terms of the other index laws. We give it an answer that is consistent with the index laws we've already gone through. So I know, for example, that if I times a to the power of -1 by a to the power of 1, from the very first index law we learned about, we keep the same base and add the powers. So I get a to the power of -1 times a to the power of 1 equals a to the power of 0. Now, I told you in a previous video that anything non-zero to the power of 0 is 1. So a to the power of 0 is equal to 1 as long as a does not equal 0, right? So to solve this and find out what a to the power of -1 equals, what I can do is get it by itself by dividing by this. So the way I undo timesing by a to the power of 1 is dividing each side by a to the power of 1. And of course, a to the power of 1 is just a. So then I'm left with a to the power of -1 equals 1 divided by a. So that's how I define negative indices. So I use this fact. A to the power of -1 is 1 divided by a. Remember, we can't raise 0 to a negative power. A has to not be 0. So how would I do something like a to the power of -2? Well, by the power to the power law, that's just a to the power of -1 squared. So it would be 1 over a squared. Similarly, a to the power of -3 is 1 on a cubed. So hopefully you are seeing a pattern. When you have a negative power, so something to the power of a negative number, you can just put it on the bottom of the fraction, but write it with a positive power. So this is the general rule for negative indices. A to the power of -b equals 1 over a to the power of b. So let's look at a few examples. So let's say we had something like 2 to the power of -5. So when people get something like this, they seem to think, okay, well, 2 to the power of 5 is 32. So 2 to the power of -5 is -32. Well, that's not right. When you have a positive number like 2, it doesn't matter whether the power is positive or negative, it will always give you a positive number. So 2 to the power of -5 still gives you a positive number. So what you do is you write a fraction and you put 1 on the top and 2 to the power of 5 on the bottom. Of course, 2 to the power of 5 is just 32. So 2 to the power of -5 is 1 over 32. 3 to the power of -7 is 1 over 3 to the power of 7. So this works for numbers, therefore it will work for letters. X to the power of, say, -6 is 1 over x to the power of 6. So you will have to simplify expressions that have more than one thing in them. So let's say we have something like 3x to the power of -6. So what you do in this case is everything that doesn't have a negative power goes on top. Everything that does have a negative power goes on the bottom, but you write it with a positive power. So something like 4y squared z to the power of -3. So put the stuff that doesn't have a negative power on top and the stuff that does have a negative power on the bottom, but write it with a positive power. Okay? So let's look at another example. So let's say we have 3a to the power of 6 over 18a to the power of 8. So we're going to use previous index laws to simplify this one. So I know that this line here means divide. So 3 over 18 simplifies to 1 over 6. A to the power of 6, divide a to the power of 8, keep the same base, subtract the power. 6 minus 8 is negative 2. So if I want to write this with a positive power, what I do is I move it to the bottom of the fraction and make the power positive. That's all you need to do. So now we're going to look at a few more complicated examples. So what if I had something like this, 1 over a to the power of negative 3? Well, here I have a negative power, but it's already on the bottom of the fraction, so I can't move it to the fraction again. So what I can do is I can simplify this part. So that would be 1 over a cubed, because this thing I've circled is a to the power of negative 3. So when you have 1 over 1 divided by something, you can just move that to the top. So that will just be a to the power of 3. So basically, if you have something with a negative power already on the bottom of a fraction, you can move it to the top. So let's have something like this. Let's say I have 1 over x to the power of minus 7. So I can just move that to the top and write it with a positive power. What if I have something like b squared over c to the negative 3? Well, I can just keep the b squared and move the c to the power of negative 3 to the top, but I write it with a positive power. So what if you raise a fraction to a negative power? So let's say I have something like 1 over 2 to the power of minus 3. So I know from previous index laws that when you raise a fraction to a power, you raise the top number to that power and you raise the bottom number to that power. Right? So I can move this thing on the bottom to the top. So I get 1 to the power of negative 3 times 2. Now you write it with a positive power. Now I can also move this to the bottom. So remember what I was saying before. If you have an expression like this, anything with a positive power on top, negative power goes to the bottom, but you write it with a positive power. So that's a bit complicated, but what I'm showing you is if you have a fraction raised to a negative power, you flip the fraction and make it a positive power. So if I have something like a over b to the power of negative 5, flip the fraction and make it a positive power. So that would just be b to the power of 5 over a to the power of 5. So let's do one more example where we have to use quite a few index laws. So let's look at this example here. Now, we do have to use quite a few index laws to simplify this. However, it's actually not that complicated. So we're going to start, before we raise it to this power, we're going to start by making the stuff inside the brackets a little easier to work with. So we'll start with the numbers. So remember I said if you have numbers and pronumerals, do the numbers separately. So 12 divided by 3 gives you 4. Now we look for things that have the same base, so x squared and x, same base. X squared divided by x is just x. I keep the y to the power of 5 as it is, haven't changed it at all, and we still have a z to the power of 4 on the bottom. Haven't changed that at all. Okay, so how are we going to simplify this? Well, if we want to raise a fraction to a negative power, remember we flip the fraction, switch the numerator and denominator around, and we make it a positive power. So what do we do now? We raise the top to this power, so z to the power of 4 to the power of 3, multiply the powers. Over 4 to the power of 3 is 64. You have to remember that you need to raise the number to the power, raise x to that power, and raising y to the power of 5 to the power of 3, keep the same base and multiply the powers. That is our final answer. Alright, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.